Hey everybody, so what we are doing today is we are going to do two DP problems. First one is painting the houses, and second one is coin change 2. And like all the DP problems, we are going to start with one of the first solution, that is a recursive solution. We're going to identify a pattern of sub-problems that are happening, overlapping sub-problems that are happening when we are doing recursion, and we are going to optimize it. So for paint house, it's a lead code problem, but it is paid one, so not everybody can see it. And most of the solutions that you will find on the web, on the internet will be they won't be going through the recursive solutions, but we are going to start with recursive solution. Let me go through the problem statement. There are a row of n houses. Each house can be painted with one of the three colors: red, blue, and green. The cost of painting each house with certain color is different. You have to paint all the houses so that no adjacent houses have same color. For example, okay, let's take a matrix of. So this is a matrix of three houses. For painting the first house, coloring red costs 17, coloring blue costs 2, and coloring green costs 17, so on and so forth. And he says that we have to minimize the cost, and in this case, the minimum cost will be 10 when we are choosing. Which one is this? Is this, yeah, blue? When we are choosing blue for first house, and after that green for second house, and for third house we are choosing 3, 5 to 7, and 3 is 10. So red, blue, green, blue, B, G, B. That is the pattern that we are going to. We need to find out how we can beat that situation. So it's just saying that it is represented by n by 3 matrix. So anybody not clear about the problem, they can ping me in chat. Neither, let's start. Okay, I'm going to code in JavaScript over here. I hope you guys will be able to understand the syntax. If you don't understand anything, just ping me, but I'll keep explaining as well. So I'm going to write a function. Should I be using the latest syntax for you guys? Okay, let's keep it very traditional. Minimize the cost, and it's going to take an input array of costs. And what we are going to do is, can anybody identify the cases over here? For example, in the last DP problems, we identify cases that if something is chosen, if something is not chosen, and like I said, in 80% of the DP problems, this is the pattern that always holds for a recursive solution. So can anybody see what are the cases? Choosing 1 or choosing 2 or choosing 3. Awesome. That is correct. Choose index 0. So now choose index 1. Now choose index 3, index 2. But before that, we have a base case which we are going to keep empty over here right now. We'll come back to that later. If color 1 is chosen for the first house, it should not be chosen for the next house, and so on. That is totally correct. Which reminds me that I need to have a helper function. So it needs to have costs. It needs to have the index I in the costs array, at which index we are, last chosen index. After that, current total cost. is what we are going to have. And rather than doing all these things in the minimum cost, we'll be doing that in helper function. Okay, Nagendra says if color 1 is chosen for the first house, it should not be chosen for the next 4 house, and so on and so forth. That is the logic, but our base cases are these three that we have chosen: index 0, index 1, and index 2. I think we are talking about the same thing over here. Okay, let's say this is int only. Okay, in Java terms, this is int. In JavaScript we use var, let, or const. They have different properties. Each one of them, I'm not going to go in details, but think it is int only. Case 1. What's the total cost in case 1 if we choose index 0, and at that time it is going to be costs I plus cost I 0, because we have chosen the 0 index, and it's going to be helper of costs. Now we are done with the ith index, and we move to the I plus 1 index, and the last chosen index was 0 over here, and the current total cost is, this is incorrect. So this is the current total cost. All right. So for case 2, what we are going to do is we are going to replace. We are still going to I plus 1 index, and then we are going to the last chosen index becomes 1 over here. Total cost becomes I 0 and 1 at ith index. And in case 3, it is going to be, we are going to I plus 1 index. Here it is, last chosen is 2. And now coming back to Nagendra's point, there are 3 conditions that are there. If the last chosen index is not equal to 0, then only we can do this. So we need to apply the conditionals for every case. And for this one, let's do this case 1. We are declaring the int outside the scope of the if statement from 52 to 54, and we are going to follow the similar pattern over here. If that case 2, somebody is writing in the chat, just give me a moment. I'll be with you right now. I'll be with you just now. All right, it should be 1, already corrected. Okay, thank you, Akshay. And what we are going to return in the end is, if we are choosing 0, 1, and 2 index, then we are going to provide the math.min of among all the cases. That is case 1, case 2, case 3. So in JavaScript, we can write any number of values, and we can just do math.min, and it will give us math.min of all the values. Alrighty, and what's the base case? We are overflowing. So if I is greater than that of costs is equal to costs dot length, then we are going to return current total cost. Is that it? Do we need anything else? Let me check with my. Yep, we need something else as well. I'm making the same mistake that I made yesterday. If a cost last index has been chosen 0 in this case where we are at last index chosen is 0 and the color is red, and that means we cannot choose for this iteration we cannot choose 0. In this case 1 will be undefined. So we have to take care that if there is no case 1, but there are cases. If there is not case 1, then there are definitely going to be 2 more cases. So case 1, case 2 and case 3 will surely be there. And case 3. Then we are going to return math.main of case 1, case 2 and case 3. And if there is no case 2, there is case 1 and case 3, then we are going to find the minimum on 1 and 3. And if there is no case 3, then we are going to find 1 and 2, and we are going to find minimum of 1 and 2. Else, we are going to return minimum out of all 3 of them. Anybody not clear about the code till now, or does anybody has any questions? The logic is very simple. We are going to choose an index. We are going to choose a color for a house or not. Do we need all these conditions? Yes, we do need. Akshay, maybe. So I'm not sure if there is math.min and the case 1 is undefined. This might throw an error. This will throw an error. We can define with infinity. Yes, that is correct. If we do that, okay, this is what Akshat is saying. That will also be a lot of code. Akshat, it's like in JavaScript, it is number.maxSafe value, max safe integer. So this is what Akshat is saying. Yes, this is what Akshat is saying. Yeah, that it will be better that way actually. It will be much lesser code and much clearer code. And return. Does that make sense? This is what you are suggesting, Akshit, right? Yes. Yes, that is a better code. And let's try to run this code and see what is happening. Undefined because we have not returned anything. Return helper. And costs and I is we are going to start with index I, and we have to put some last chosen index is some random number which is not equal to Not min, max safe integer. That is the mistake that I had done. I was taking the min safe integer everywhere. And in this case, it is 10, which is the required answer. This is the answer in the blue highlight. It is showing the answer for us. And let's try to change the numbers. Let's try to do 1 over here. It is 9. In this case, it will be choosing 1, 5, and 3. So 9 should be the answer, which is correct. So anybody not clear about the recursive solution that we have? Basically, the idea is pretty simple. Okay, I won't waste much of the time over here, since the recursive solution is already there. Let's try to see what are the sub problems that we are finding in the recursive solution. Alrighty, 17 over here. You guys can unmute yourself and ask the question. Could you please explain what is happening with max safe integer? Okay, Nagendra, this is very very JavaScript syntax. So it's similar to that of integer max value in Java. You can unmute yourself and we can have a conversation about that. What is your doubt over here? So this is nothing but like in Java, it is integer dot max value, which is like we take the infinity in terms of code.
Yeah, I get you, Jasmine.
All right, awesome. Let's see what are the subproblems that are happening right now. So, okay, take this case. This is 17, okay? And the answer should be 10, which is 10. On a side note, if you guys know how I can, so this is in VS Code. I have an extension called Coca, and I am able to visualize the code in VS Code itself. I can run the code. I can console log it. That is system.out.print in the along with the code itself. If somebody knows in IntelliJ or Eclipse, these kind of things are there, then do let me know. All right, for Java. Okay, let me remove this. Okay, let's see what are the subproblems which are happening over here. In let's take the case in which we are choosing 0th index for the first house. So the total cost becomes 17, 0, and 0 because we have chosen 17 among this. And in the next one, we have chosen, let's say, so what we are doing basically in recursive solution is we are finding all the possible combinations that can be there of the costs. And then we are going to compare them with each other so that we reach the minimum. So in the first scenario, let's say the recursive solution finds out what's the cost if we are choosing 17 with the first one and 16 for the second one and 14 for the third one, which is equal to 16 plus 14, 30 and plus 17 is 47. All right. Then for staying at 0th index itself, it finds out what's the cost if we choose 17 and then 5 and then 14. So these are all the possible solutions if we have chosen 17 only. That is the 0th index in the matrix for the 0th index for the first house. These are the possible combinations that we have. Now let's come back to if we are choosing second index in the first house, what are the combinations that we are calculating? We are calculating 0, 0, 0, 17 and And look at this highlighted area. We are calculating for the second and third house, what is the total cost going forward if we are choosing 16 and 14. Didn't we find the same thing, that this highlighted sub problem as that of highlighted sub problem? This is the repeat that we are doing in the recursive solution. We are finding the same things, the highlighted thing over here and the highlighted thing over here. Let's go to the next one. Let's see, this one and this one are same. Sorry, don't ignore this one. This is not. This one and the above one are already same. So these are the sub problems that we are overlapping sub problems that we are doing again and again, and we don't need to do them. So let's optimize our solution. We can optimize the solution with two ways. We can do an extra DP array or matrix, but he says that we have to optimize so in the problem statement, he says that we have to optimize for the space, O of one space over here. In lead code also he says the same thing. So if we want to do it in O of one, then let's write a function over here again, min cost. What we are going to do is we are going to mutate the same array, like I think Akshit suggested yesterday, if we can mutate the same array in the other problem as well. So costs, we don't need a helper function over here. We are just going to have this thing over here. And what we are going to do is we are going to start. We cannot start from 0th index. We are going to. Okay, we have 10 minutes. I'm going to rush through this problem. Okay. For let I is equal to 0, I is less than costs dot length I plus plus, and what we are going to find is costs I 0 plus equals. Let me write the code and then I'll explain what I'm doing over here. Let me math.min for I minus 1 index and 2. So what are we doing over here? I'm saying, okay, for the first index, I'm going to maintain all the same terms like that, like 17. What were the terms? 17. Oh, I deleted them. 17. There was something over here and 17 over here. What was here was there was something here, right? It was 2. Okay. And the answer in this case was 16. Here it was 5. Gosh, why did I delete? Does anybody remember the initial happy case that we had taken? Yeah, loop will be starting from 1. My mistake. Loop will be starting from 1. What we are going to maintain is for the 0th index of the cost array, we are going to have costs as same. So once we go to the next index in the cost array, we are going to say if we are choosing 0th index, this is nothing but choosing index 0. Then we are going to find the costs that were minimum among, if this one is chosen, the highlighted one, this one is chosen, then the cost over here is going to be, Okay. Does anybody remember what was the initial example that I gave? 16. Awesome, Mukesh. I highly appreciate. This is pretty much needed. 1439. Let me check if that is the correct example that we had taken. Okay. 2, 5, and 3. Yes, that is correct. The answer should be 10 over here. Okay. What I'm doing is I'm going to keep the first array in the costs matrix similar. Then I'm going to go to the next index, that is 1. Like we started our loop from 1, and we are going to see what is the total cost over here. If we are choosing this one, then apparently we cannot choose this in the last array, right? 17 could not be chosen, and we are going to find the minimum out of 2 and 17. What is a minimum out of 2 and 17 is 2. So our total cost becomes 18 over here. And when we have chosen 16, we could not choose 2 in the last array, and minimum among 17 and 17 is 17 again. 16 plus 17 is 33. If we are choosing 5 over here, and then we could choose among 2 and 17, and 2 is the minimum, 5 plus 2 is 7. All right, and once we go to this point, we have 14, and among 18, 33 and 7, we are going to choose 7. So this becomes 21. This becomes 21. Then among 3, so 3 is over here, we could choose among 7 or 18. We choose 7 because 7 is the minimum. 7 plus 3 is 10. And for 9, what we are calculating is minimum among 18 and 33. Minimum among 18 and 33 is 18, and 18 plus what was here 9 is 27. So once we reach the end of the array, we are going to just take the minimum out of it. So let me just write the code and things which will be much more clearer to you guys. 1, if we are choosing 1 over here, and if we are choosing 2 over here, then we are comparing with 0 and 1. 2, if it is 2, 0 and 1. And in the end, we are going to just return math.min of, let's say, let k is equal to costs dot length minus 1. That is the last index we are saying we are going to reach right here. And math dot return math dot min of costs among the last 3 houses, last 3 calculated values in the last index of the cost array, cost matrix, sorry. Costs k 1 and costs. I have not looked at the chat right now. Let me see if everything is correct. All right. We just need to have one edge case over here. What if there is no costs dot length? I'll see the chat right in a couple of minutes. Then we are going to return 0. Okay, let me see what's there in chat. It should go till less than or equal to n. What is n? Cost length. Yes, it is going up to cost length. So okay, it's going up. It's going to I0, then I1, then I2. The cost length is going to be 3 in this case. Does that make sense to you, Akshat? So the cost length is 3 in this case, and we are going to go to less than that of 3 up to index 2, right? So in this cost array, index 0 is this whole array 17 to 17. The index 1 is 18, 33, 7, and index 2 is 12, 21, 10, 27. And let's try to run this thing. Console.log array and console min costs of array. And now I'm going to write the array over here. I'll come back to your question once again if you're not clear, Akshit. Just give me a moment. We have less than 1 minute also. Now I'm going to use feedback provided from Mukesh 16, 5, 60, 5, and 14, 3, 9. Okay, we might cut in between because it is less than 1 minute. So I'll post the Zoom link once again in the channel, and we'll finish off this problem. Okay. And